Okay, now we're going to do some operations with radicals. And the one thing that often is confusing about them is that radical sign gets in the way of your thinking because you're not used to it. But I want to back you up onto something that's much, much simpler that you've done a million times. If I ask you, hey, what's 2a plus 5a? Pretty much all of you right away would say, hey, that's 7a. Or if I said, I have 2 oranges and I'm going to give you 5 more. How many total oranges is that? That's 7 oranges. Same idea works here. If I have 2 square root of 5, and I'm going to add another 5 square root of 5, that's going to give me 7 square roots of 5. So we wouldn't read it that way mathematically, but that's the idea, right? I have 2 here, 5 there, I'm adding them, I'm going to have 7. 7 root 5. Okay, so in a way you can kind of just consider these square roots to work a lot like variables, in the same sense that if this was 2 oranges plus 5 apples, well, you couldn't combine them. And if this was 2a plus 5b, you couldn't combine them. And if this was the square root of 5 and this one was the square root of 7, you can't combine them. And this is very, very same way. Okay? So let's show you how this works. Okay, so let's start with the simple stuff. This says 14 square root 3 minus 6 square root 3. Well, these are the same. I have 14 of them. I'm taking away 6. So how many do I have left? I have 8. I have 8 root 3 left. That's it. Done and done. This next one, I have 3 square roots of 7, 3 root 7. I'm going to add 5 root 2. Well, there's a problem. This is different than that. They're different terms. They're not like. And so this is already simplified. There's nothing more you can do. Okay? All right, now I have something like this. Well, it might appear on the surface to not be able to go together because I have 32 and 8. But if you remember, going back to the last section, that you could simplify some things. I can't simplify the square root of 3, I can't simplify the square root of 7 or the square root of 2, but I can simplify this because I can change the square root of 32 to the square root of 16 and the square root of 2. 2 times 16 is 32. 16 is on that list that we had up earlier of things we could take the square root of. And hopefully in your head you're thinking of a number that goes into 8 that you can take the square root of. I will give just a moment for you to think of that number. And hopefully you already came up with the number 4. 4 goes into 8, and that's the square root of 4 times the square root of 2. Now I take the square root of each piece. So the square root of 16 is 4, and I still have that root 2. It's still there. Still have that minus. Square root of 4 is 2. And I can't take the square root of that 2. Again, once you take the square root, you remove the symbol. And then now you can see that this problem is relatively simple. We got 4 root 2 minus 2 root 2 is 2 root 2. Okay, for the sake of time, I'm going to simplify this one quickly. This one will simplify to 5 root 2. This one will simplify to 4 root 3t. And then this one will not simplify at all. And in this case, we've got the square root of 2, the square root of 3t, and the square root of 2t. Those are all different terms. This would be it. There'd be no more simplifying. If both of these had been 3t, then I could combine those. And if this was 3t, and then I have negative 4 plus 3 is negative 1, or just minus square root of 3t. Okay, moving forward. If I'm multiplying, I do similar type of things. I multiply, what I would say is multiply outsides by outsides, insides by insides. So 2's on the outside, nothing else is, so it stays there. And then I multiply inside by inside. 15 times 3 is 45, p squared. And then I got to do the simplifying step. So this is 2, and I'm going very quickly now. A number that goes inside of 45 is 9, and I can take the square root of p squared. So I can take the square root of those. What's left over is 5. 5 times 9p squared. is 45p squared. So if I've broken it apart, I can take the square root of that, so that's 3p. This right here is 3p, but 2 times 3p is 6p, and then square root 5. Now, because it didn't say assume non-negative, all that stuff, I have to remember that, the absolute value. Okay? Here I have something that I have to distribute, and again multiply outsides by outsides, insides by insides. So multiplying this to the inside is 12t squared, minus multiplying that to the inside is 4t squared. And now I'm going to break this apart. The square root of, I'm going to simplify this relatively quickly, but this going inside of 12 is 4, and t squared I can take the square root of. What is left then is 3, so that is still 12t squared. I can actually just take the square root of that. That is just 2t. And then I'm going to simplify that. The square root of 4 is 2, the square root of t squared is t, square root of 3 minus 2t. And that's it. I can't simplify those because the square root of 3 makes it a different term than one that doesn't have the square root of 3. And I will let you, for the sake of time, do this one. But just like here you would have distributed, here you would distribute again. But you would do it twice. You would distribute the 3, and you would distribute the negative 2 twice. Multiply outsides by outsides, inside by insides, and simplify. And see, and pause it now, do it yourself, and see if you get the answer I'm just about to write up. Have you paused it yet? You should pause it, because I'm about to write this thing up. If you didn't get that answer, ask me in class, and I'll show you how that worked.